Hey, what's up everybody? TooTallToby here, and in today's Onshape quick tip, we're going to talk about mate connectors. Now, earlier this year, we published a video showing how to use mate connectors to put components together at the assembly level, but in today's video, we're going to take a really cool dive into the world of mate connectors at the Part Studio level, and we're going to show you how you can use mate connectors to do things like creating and locating holes, how to use mate connectors to do things like sketching on planes that don't even exist, by leveraging the power of mate connectors. And we're going to show you how to use mate connectors to do things like taking a part within a part studio and making a copy of that part in a new location. Of course, we're going to sprinkle in a lot of additional tips and tricks along the way. So if that all sounds good to you, be sure to hit the like button on this video and get ready to leave me some comments down below. Let me know if you see anything really cool that you didn't know about, and let me know if you have any questions or if there's anything you'd like to see in a future video dealing with the wonderful world of mate connectors. All right, let's get started here by just doing a quick review of the world of assemblies in Onshape and how mate connectors work in assemblies. So we can see here that this component is free to float around, and our goal is to create relationships between these components so that the mechanism functions similar to how it will function in the real world. So to do that, we create what are called mates, and one of the most common mates in Onshape is called the fastened mate. Now, Onshape works a little different from other CAD programs because instead of creating mates between faces, what Onshape does is it activates what are called implicit mate connectors. And you can see this occurring whenever I take my mouse and I put it over a face of the model. This mate connector kind of shows up, it kind of jumps around a little bit depending on where my mouse is. And the mate connector has three axes. It's got this primary axis here, and then it's got the secondary and tertiary axis, and they all come together at one point, which is what's known as the location of the mate connector. It's basically a coordinate system or an XYZ location with a center point. So if I click on this face here to activate the implicit mate connector at the center of that face, and I click on this face here to activate the implicit mate connector at the center of that face, those two components are brought together because that's what the fastened mate type does. It aligns the X, Y, and Z of both of those mate connectors. And so we can see those two components are brought together. Now, part of the reason I wanted to do this quick review with you is to show you that sometimes when you do a mate at the assembly level, it doesn't quite line up the way you were hoping it would. And in this case, what we can see is that the blue component here is interfering with the gray component with the vice pad here. We've got this little interference here. So to resolve that, what we can do is we can redefine the location of the mate connector. And the way we do that is by clicking on this little icon right here. And this is a little bit of foreshadowing. We're going to see a lot of this in today's presentation. And that's why I wanted to review this with you here. So we're going to click on this little icon here, the definition of the mate connector on the vice pad, and we're going to adjust its Y location by 2 millimeters. So we're just going to adjust this by 2. Now watch that gray pad in the background. I'm going to type in 2, enter, and we see that pad move up a little bit. And so now let's take a look and see if that took care of that interference. And we roll this around, and oh yeah, that looks a lot better. We no longer have that interference between the vice and the vice pad. Now, like I said, I wanted to use this as an opportunity to review a little bit of what was covered in that earlier video. You can certainly watch the entire video to learn more about mates at the assembly level, but this also provides a great foundation for us to understand some of what we're going to be doing here at the Part Studio level. All right, so let's jump into Part Studio mode and show some really cool ways that we can save time by utilizing mate connectors at the Part Studio level. Now, this document is called Toby's Mate Connector Examples. This is stored in the shared repository at Onshape, so if you want to click along with me throughout this video, you can pause the video, search for this document in the shared directory or in Onshape, and then you can open up this document. It's got 3 Part Studios in it that we're going to be working on and showing off some really cool functionality of mate connectors. So in this first Part Studio, it's called Clevis Mount. I'm going to take the rollback bar here and I'm just going to roll it back to before the last 2 features, so just above upper hole. And what we're going to introduce here is probably something pretty common that a lot of users already know about, and that is that you can locate holes using mate connectors. So I click on the hole command here in Onshape, and we see that the prompt says select sketch points to place or to locate holes. But next to this prompt here, you can see that we've got this icon. And this is the icon that I really want you to keep your eyes peeled for moving forward in your Onshape career, because this is the icon that indicates that alternatively, we could use make connectors to do that task, in this case, to locate the holes. So I'm going to click on that icon one time, and then I'm going to move my mouse out on the screen. And now you see, just like in assembly mode, we are able to bring up this implicit mate connector, and it shows up at the center of a face or the midpoint of an edge or at the center of a circular edge. So in the case of this part here, where we've got these 4 circular radii on the corner, we can choose these 4 locations here because these counter bores are concentric to those corners, hit the green check mark, and boom, we are done creating that counter bored hole in this document. So that is a really nice time saver for locating holes. Now, sometimes that is the perfect location for that hole. Sometimes you want to adjust it slightly. So let me create another hole here. This time I'm just going to create a simple hole, and I'll give this thing a diameter of, let's say, 10 millimeters. So a simple hole here, 10 millimeters in diameter. I'm going to use the make connector option, and I'm going to locate that hole right here, right at the center of this arc. But then what I'm going to realize is it actually needs to be a little bit lower or a little bit higher. Well, what we can do is we can click on this icon here to kind of redefine the location of that implicit mate connector. In other words, we can adjust one of these 3 axes here to either change the orientation or to change the XYZ location. So I'm going to choose that little button there. Mate connector is kind of like the mini, not this one. This is like the bigger one. This is like the mini mate connector button. I'll click on that button, and then here you can see that I can adjust the Y location by -5 millimeters and enter. And look at that, that moved that hole down just slightly. Maybe we'll move it down a little further. Let's move it down -25 millimeters. There we go. Move that kind of down towards the bottom. So the point here is that when you are trying to locate holes, you might not have the exact location from a mate connector, but you can adjust that, and you can do that on the fly. So another example of this might be, what if this part had sharp corners? Let's say I roll this bar all the way back up to the top here, all the way back up to that main base. So what if this part had sharp corners? Well, what I could do here is I could choose the hole command, hole, and then I could choose to locate this hole. Let's go back to our counter bores here. I could choose to locate this hole using make connectors. So select make connectors, come out here onto the part, and I'm just going to choose right here, which is going to be the absolute corner of that part. Well, that radius that we had on there a moment ago was 40 millimeters. So what I could do is I could choose this icon here, make connector, the little mini make connector icon, and then I could choose to offset the Y by, or the X here by -40, and I could choose to offset the Y by 40 as well. And then look at that, it drops that hole right there, right in the middle of the part. That is what we like to see. So now I've got the first instance of that hole. How am I going to get those other instances? Well, I could do this with a mirror command. I could also do it with a circular pattern command. And the circular pattern command is one that I always get comments about when I make YouTube videos, when I make tutorials for Onshape. There's always people in the comments saying, hey, you don't have to create an axis. You could just use a make connector. So let's give it a try here. Let's see what they're talking about. So we fly out this menu for our patterns. We choose the circular pattern command. And now here we're going to choose features to pattern. So feature pattern. What are we going to pattern? We're going to pattern this hole that we just created. And then for the axis of the pattern, well, I don't have an axis. I don't have a vertical line that I want to use. I don't have a circular edge that I want to use. But what I do have is this button here that says select make connector. So I choose that button. Now you'll see I can take my mouse out on the screen, and I can choose any of these locations where the make connector is, including dead center on the part. Well, this part is square, so this actually works out perfect. So you can use a make connector to drive the center axis of a circular pattern as well. Again, be on the lookout for this icon here. Anytime you see that icon, that means you could use a make connector to accomplish that task. All right, let's show a couple of more cool things with this model. I think I'm going to get rid of that circular pattern, that hole. We already have those a little bit later. Let me just roll down through here towards the end of this model. And here we can see that at the end of this model, what we've also got, let me just get rid of that extra 10 millimeter hole. I don't think we need that. So what we've also got here at the end of this model is we've got this hole here at the top running through the model. Now this one I think is really cool, and I've really been finding some good spots to use this. So what I'm going to do is I'm going to put a little notch here on this face, just center point rectangle right here at the center of this hole. Let's say we make that 6 wide by 36 high. And now we're going to extrude cut that. So extrude, remove. Let's just bring that in like 2 millimeters, just a little notch there on that hole. Now what I want to do is I want to mirror that so it also shows up here on this face. Well, guess what? I don't have a plane. I don't have a plane that I can just select that's running right through the center of that vertical clevis. But what I do have is I do have a mate connector, and that mate connector can exist right here, right at the middle of this edge. So let's go into the mirror command here in Onshape. So I'm going to choose mirror. And now for my entities to mirror, let's change this to a feature mirror. Entities to mirror, I'm going to choose this little notch that I just created. And then for my mirror plane, you'll notice that next to the prompt, oh, there it is. This guy is going to become our best friend. We really like this icon. So we click on that icon to select a mate connector. And now here we can take our mouse and we can click here on this edge. Now, what you want to notice is that the mate connector is kind of shaped like a puck, like a hockey puck. And so it definitely has like a flat orientation. And that flat orientation is going to be your mirror plane. Okay, so you'll notice here, it's kind of like they got that flat orientation at the middle of that edge. So I'm going to click there once that preview shows up, and there we see the preview of the mirror. It is showing up red, which indicates that there's an error. But if you've seen any of my other videos, you know that anytime I do a pattern and the pattern has an error, the very first thing I do is I hit the check mark here for reapply feature. So let's see if that fixes it. And oh yeah, that fixed it. That's what we like to see. And so we hit the green check mark, and there we go. And I think that's where we're going to stop with this example, this clevis mount example. But we really covered some good material there. We covered the idea that you can use mate connectors to locate holes at the center of circular edges. Very, very useful. When you do locate a hole, you can also relocate it by adjusting the properties of that mate connector. We showed that you can use a mate connector to drive the location of the axis of a circular pattern. And we showed that you can use a mate connector to define the plane to do a mirror. So let me know down below in the comments, what was your favorite of those? And let's move on to the next example, the lantern example, to show some other cool stuff that we can do. All right, so for the lantern, this is pretty cool. If I take the rollback bar here and I roll back, let's roll back to say, let's see here, we got the lower hex space, then we've got the sketch 2 here, we got the second hex space, then we've got the sketch 3 here, and ooh, wow. That's kind of weird. That sketch 3 is just kind of floating up there in space, but it's not on a sketch plane. Well, this is something really powerful that you can do with these mate connectors. You can see here that I want to create a sketch plane up top there, so I can create kind of this upper area for this lantern. So to create that upper area, what I can do is I can choose to create a new sketch. So just click on the sketch command here, new sketch, and then here you see it saying, okay, well, where do you want to sketch? Choose a sketch plane. But then look at this, next to that prompt for the sketch plane, we've got our old friend, the you can use a mate connector to achieve this task button. So I'm going to choose that button there, and then I'm going to choose on this face here. And now, as you remember from previous examples, we can choose the little mini button to redefine the location of that mate connector. And we can say that we want that mate connector to be located here in Z at a height of 150. So we do 150, enter, and that's it. Now we're ready to start sketching in that new location kind of floating up here in space. So it's just a little thing, but it does make it nice because then you don't have to go in and create a new sketch plane. You can just right away start sketching at this location, which is defined by that mate connector. So now what we could do is we could jump into the hex command and we could drop in a hex here at the appropriate size. Pretty cool stuff, pretty cool stuff. And so now we can see here that we did create that hex up top, and then we created this hex here above the windows, and we use that to help drive some of this other geometry, like this next sketch plane here. Look, once again, another sketch plane that's defined not by a plane, but being defined here by a mate connector. And you'll notice here, if I go into the settings, we offset that one at 52 in Z. So we have a new location here up above that section of the lantern. And then what we can see is that we were able to create a blend there between those two areas, a little lofted area, a little blend there between those two areas. And then we do something kind of similar down below here. We create a blend here for this cage area, for this kind of window area. And then let me just hide these other bodies here, hide this body, hide this body. We shell that area out, and then we cut one of the windows into that area. So now what I want to show you is another really important kind of a magic button when it comes to working with these mate connectors, and that is the shift key. So just like we did earlier, I'm going to use the circular pattern command. I'm going to make a feature pattern of that window. So for the features to pattern, I'll just choose this face here of the window. And then for the axis to pattern, I'm going to choose the select mate connector button. But But this time when I go out here on the screen, what I want to do is I want to get the middle of this face. You see how kind of like the middle of that face shows up, but I can't get over there. So there's the middle of the face. I can't get over there to select the middle of that face. Well, the trick here is you put your mouse over the planar face and then you hold the shift key on your keyboard. So now I'm holding the shift key. Now what happens is as I move around the screen, the focus kind of stays on that planar face where I was mousing over when I held the shift key. And that means I can select in the middle. If I let go of the shift key, you see now I can select any other face. But if you put your mouse over that face and then hold shift, now you can kind of at will move around to any of these nodes for the mate connector location. And in this case, I'm going to choose the one right in the middle. I let go of shift, I let go of my mouse, I change that instance count to 6, enter, enter. Look at that. We were able to create that circular pattern for the cage here on the inside of this lantern. So some pretty cool stuff there. When you're working in Onshape, you can use the mate connector function to define a planar location for your sketches, and then you can offset that by adjusting the definition of that mate connector. And you want to remember that when you're defining things like the center axis location, or you need to define like a weird location on a face and you're having trouble selecting that, hold your mouse over that face and then hold shift and then see if that makes it a little bit easier to select that desired node. All right, we've got one more example of a part studio. We're going to do that in the next section of the video, but let me know down below in the comments if you liked what you learned in this section. So in this last example of how we can use mate connectors to save time in the Part Studio, we're going to once again talk about how we can create a sketch without even needing to create a sketch plane. But this time we're going to show it using a sweep path. And this is something that I do all the time. A lot of my models have sweeps in them. So I'm regularly creating a sweep path. And then usually what I do is make a new sketch plane perpendicular to the path at the endpoint. But now that we know about mate connectors, we can choose to create a new sketch, and then we can click on this little button here, our new best friend here. You can click on this button here, and now you'll notice that when you take your mouse over the sweep path, you can generate these implicit mate connectors, and you can select one of these implicit mate connectors to define the location of your new 2D sketch. So now right at that endpoint of that path, I can create a sketch with a diameter of 5 millimeters, a circle with a diameter of 5 millimeters. I can exit that sketch, and I now have my sweep profile and my sweep path, which means that I can now take that sweep profile and sweep it along that path to create this hook wire here. So pretty cool stuff there in Onshape, the ability to create that sketch geometry without needing to create a sketch plane by using that mate connector. The other thing that we can do here is we can, we'll see here, we'll roll forward here. We'll make this wire tip. This is where the wooden ball will go. We've also got one down here at the bottom. This one at the bottom is actually just a little bit shorter. It's about 2 millimeters shorter than the one at the top. And then you'll see here that if we roll forward, we've created a revolve here of this wooden ball. Now, at this point, you kind of need to make a decision about what you're going to be doing with your geometry downstream. If you're just trying to create a mock-up here in the Part Studio, or if you're doing a 3D print or something like that, then it's fine to create multiple instances of the same component. However, if your plan is to create a bill of materials and you want to show the correct quantities and things like that, then you might be better off just making one of each component, putting this Part Studio into an assembly, and then making the copies of the components and locating those components at the assembly level. I know that's a little bit off topic here from mate connectors, but I just wanted to mention that before I show you this next function. So the next function is, if we are going to be just working here at the Part Studio level, how do we get an exact copy of this part within the Part Studio, but to be located down here? You know, I can't do it with a pattern. I can't do it with like a linear pattern or a circular pattern. And so what do? Do I maybe just create a new sketch down here, create another sketch of that revolved shape, and then revolve that about an axis to create that second wooden ball? That's actually how I did it the first time. And then somebody in the comments said, hey, you could just make a copy of that using mate connectors. Like, mate connectors can solve everything. If you guys read my comments from my tutorial videos, you'll see there's a lot of people who say, hey, you know, you could have done that with a mate connector. And so I'm really glad to be learning a lot of this functionality now, because I've just been saving so much time and very happy to share it with all of you. Thumbs up for the amazing comment section out there. So when we want to create a copy of an exact solid body or a part here and relocate it to a new spot, what we can do is we can use the transform transform command. Now, normally when you think of the transform command, you think of something like translate by XYZ, and you think of maybe selecting this part here and then just moving that part into a new location. And that certainly is one way that you can use the transform command. However, you can also use a check mark within the transform command. So let me search for that transform command again. Enter, and there's a check mark here that lets you make a copy of this part into a new location. And then to define that new location, you could use translate by line or translate by XYZ, but you can also use transform by mate connectors. So in this case, probably the best way to relocate this is to select the wooden ball here to be copied, and then to hide the wooden ball here. So hide the wooden ball down here at the bottom of the screen in the parts list. And then here where it says transform by mate connector, the from mate connector could be this face here. And then the to mate connector could be the mate connector at the center of this face down here. And look at that. We made a perfect copy of that part into that new location. We can show the original, and now we've got two instances of that part here within this part studio. Now, the one problem that we've got here is that this part is actually interfering with the wire down below here. And this kind of harkens back to what we showed at the very beginning of this video. We showed that if you go into the definition of that mate connector and you click on this little kind of mini mate connector icon here, you can redefine the location of that mate connector. And in this case, it looks like it's the blue axis that needs to be redefined. So that's going to be the blue axis here, the Z axis. Let's increase that by 2 millimeters, enter, and I am liking the way that preview looks. And so we can hit the green check mark, and that does it. That clears up that interference for that part. And I think that's where we're going to stop here with this coat hanger rack example. In that example, we showed how you can sketch your 2D profile for a sweep by using a mate connector and using the endpoint of the sweep path. And then we also showed how you can make a copy of a part within a part studio by using a mate connector to facilitate that transform command. So I hope you like all the examples that we saw here today. If you did, be sure to hit the like button on this video. Be sure to subscribe to the channel and let us know down below in the comments, what was the coolest thing you learned from this video? And is there anything else that you want me to show in a future video dealing with the wonderful world of mate connectors? And I will look forward to seeing all of you in the next TooTallToby Onshape quick tip video.